And now, please give a warm welcome to the amazing global AI leader and chief decision scientist of Google, Cassie Kozyrkov, who will tell us how to stay safe in the AI future.
Hello, Sophia. I am so excited and delighted to be here with you today. My name is Cassie Kozyrkov. I serve as Chief Decision Scientist at Google. And if you've ever interacted with any Google product, you have interacted with AI. So AI is all around us already. You're all using it. So in this talk, I'm not going to do the classic keynote where I'm like, hey, everybody, you should all be using AI, building AI, getting more AI. No, I want to go beyond that. I want to talk to you about how to do it safely and effectively, how to be a responsible builder of AI, a responsible leader in our AI future, and a responsible participant and citizen in this future that we're all building together. Because AI is everywhere already, it's definitely here to stay, but it helps to have a safer way of thinking about it. So that's what I'm going to take you through, and if you've never heard of machine learning and AI, I'll also gently explain what the thing is there, and spoiler alert, it's not magic. It's something far, far simpler. But first, I'm going to beg your indulgence, please, in this talk, because I will be using the terms AI, artificial intelligence, and machine learning interchangeably. Now look, I am an ex-academic. I get that they're technically different things, but industry is kind of using them as synonyms too, and I don't mind this so much. See, when you start your projects, it doesn't matter if you know in advance whether you need AI or machine learning, you're going to start everything the same way. So it's kind of okay that you're using these as synonyms. That's one reason. The other reason is that my favorite definition of the difference between machine learning and AI is on the next slide. If it is written in Python, it is probably machine learning, and if it is written in PowerPoint, it's probably AI. A little humor to wake you up this morning. All right, so there's a lot of buzz in this space. I want to break it down for you. What is this AI thing actually about? What is its promise? Why is it cool? So let's go back to the most basics. AI versus traditional programming. What's the deal there? So in traditional programming, what are we doing? So first, anytime we're using a computer, we've got inputs, we want outputs, we need to get from one to the other, right? Right. So how do we get there? From a model in the middle. And the model, that's just a fancy word for a recipe. In traditional programming, where does that come from? That is handcrafted code that a programmer, a developer writes. So where does that code come from, right? They think very carefully about the task, and then they communicate with the universe in some way, right? They think very carefully about how to solve it. And then once they're inspired, they will explain to the computer by writing code, by handcrafting those instructions, what the computer should do to turn the inputs into the outputs. That's how it works. Now, in machine learning, there is one important difference. Instead of explaining our wishes with instructions, we're not using instructions anymore. We're still programming the computer, but in a different way. Instead of explaining with instructions, we now program with examples, and that is another word for data. So we put data or examples in there. The machine learning algorithm then finds patterns in those examples and creates the recipe for us. So that same thing, that model, that code that the programmer used to write, that's now created from data by the algorithm. So if you wanted in just one slide what the deal is with machine learning and AI, what it's about, there it is. I actually quite like the suggestion. Some people said maybe we should have called it Software 2.0. I love that, because what this is a revolution in how you write code. It's a different way to talk to machines. It's a communication revolution. And here's why it's really powerful. There are some tasks that it's really easy for us to express exactly how to do it. First you do that, then you do that, then you do that, then boom, it's automated. But for other tasks, we know how to do it, but it's very hard for us to say how we did it. So the toy one, the classic, is the cat, not cat example. You look at a bunch of photographs, and as you're looking at those photographs, I hope that it's pretty obvious to everybody in this room which one is a cat and which one isn't a cat, right? That is easy for you to do. So if you had to label those photographs, super simple. But now, consider what are you doing, what is your brain doing with each individual pixel to give you that answer? Could you express that? Like, take the pixel on the left, and then what do we do with it? And then the pixel next to it, what do we do with that to get the answer cat, not cat? That is really hard and complicated. And if you start thinking about stitching a solution, you're like, oh, look for little triangles, those might be ears, that's how they used to go about these tasks. Well, what if it's one of those cats with the flat ears, those Scottish folds? Your solution's not going to work for that. So this is a really, really difficult one to automate with instructions. But if instead we give the computer a lot of examples, a lot of data, then we have a shot at automating it. Because the real recipe is going to be a very difficult, long, complicated recipe. This is also what you need to understand about AI. It's not going to be simple. If the solution was simple, a programmer would have come up with that themselves. You don't need AI to automate that. It is because the solution is so unwieldy and long and complicated and ineffable, you can't say it, that you start to need to rely on tools like this. But I also want to point out that it's not something fundamentally new, like conceptually. It's just about communication. It's new because this is how we're now communicating with machines, but when we think about how we communicate with one another, we've always done this, right? When you think about the last time that you taught someone to do a task for you, right? You were getting them to automate something for you, bring you the right coffee or whatever else it might be, drive you somewhere, teaching your kids to drive or something. Think about the way that you go about teaching. Sometimes the right way is to give explicit instructions. Do this, then do that, then do that. Sometimes the right way is to say, here, watch me do it a few times. Here are a few examples of what I'm looking for. And now you think about what's in common among these examples, and you come up with the recipe for yourself. So you're already doing this with humans. We already have these two ways of communicating with one another. The machine learning and AI revolution is a communication revolution where we get this second mode of communication with machines. Before, it was instructions only. So the only thing you can automate is something where you can say exactly how to do the task. Now we're doing better than that, because now we have this other way of saying what we want. And the reason that we've waited so long to get here with AI is that for a lot of these tasks, you need a lot of examples, a lot more than you would need to give people. And so we needed the computing power, the storage and processing power to handle all of that. That's why AI is a thing that is now modern, current. But as a concept, this is all it is. Now that's both disappointing and extremely empowering. And I want to encourage you to see the really useful aspects of this, that we can now automate things even if we cannot say how to do the task, even if we don't know. How cool is that? And this is a really useful technology. Like all useful technology, it empowers and extends you. It is a lever. It increases your ability to have impact on the world. Amazing. But watch out. As you enlarge yourself with technology, you also make it easier to step on the people around you. So with great power comes great responsibility here. As you increase your impact, you have to be careful and you have to be thoughtful about where you point these tools and how you apply them, which is why I'm hoping I've got a lot of leaders in this audience. This is a talk not just for citizens and technical people, developers. Leaders really need to think about their responsibility in light of what it means to extend yourself with technology. But look, this isn't AI specific, right? This is about all useful technology that increases an individual's ability to impact their world. In fact, have you ever noticed that a lot of the topics around AI ethics, right? If you ever go see some talks about AI ethics, those topics, if you really think about it, they're not unique to AI. So few of them are actually talking about AI-specific problems. I mean, look, I really hope that you're not the kind of villain who would want to perpetuate the unfair treatment of people or disrupt labor markets, upset human relationships, create complex technologies that you can't get rid of that make life worse, not better. I hope you don't want to do these things. But if you did, you don't need AI to do that. And all the ethics conversations around technology, all the different technologies that let you do this stuff, those are important conversations. I am so glad that we're having them. We should be having these conversations. They're not AI specific. Now, okay, because they're so important, I'm glad that AI is drawing attention to them, right? It's making more people want to have those conversations. But don't get lost in the details. See, I think there's an analogy here to teaching geology using pet rocks. Once something has a face on it, once it reminds you of you, you pay attention. It's all in good fun until the pet rock geology lesson turns into pet rock psychology. Right? Just because something reminds you of you doesn't mean it has a brain. Doesn't mean it thinks. Doesn't mean it's a person. And we don't want to be led into some very distracting areas where we treat AI the same way as our tendency to, talk to a pet rock and have conversations with it. Remember, robots, AI, machines, they are just another kind of pet rock. It's an object with a face painted on it. On either side of this technology are humans. A lot of the time, we're thinking about the technology and we're thinking about the users of the technology or the people affected by it downstream. We forget that all technology comes from people. There are people on the front end of it too. And a technology is just a way of transmitting the wishes of those folks in a more powerful way onto the world. So don't lose sight of this human piece. Robots are just another kind of pet rock. So none of this stuff so far is AI specific, but I promise you I will find you an AI specific issue, and we're going to talk about that a lot. And to find it, we need to remind ourselves, what is AI actually all about? It is a set of tools. What are these tools for? They are for programming, for turning patterns in data into code. So if you have never thought about whose job AI actually automates, I'm about to blow your mind. So who gets out of a job from AI? Whose job is automated? It is the programmer's job. A developer's job is to automate everyone else's work. Machine learning and AI automates the developer's work. However, with today's technology, there is still plenty of work for developers to do. There is a lot of huffing and puffing to get your algorithm to play nicely with your data, to move data around at scale, to create those pipelines. So there's plenty for everyone to do. It's actually increasing the amount of work that there is, not decreasing it. But in here, we start to find that AI-specific issue. Here it comes. The difference between AI and other technologies is that it allows you to be thoughtless. The amount of built-in human thoughtfulness that will be involved in automating any task goes down. Okay, that's both awesome and really scary. Let me explain this more clearly. When you think about getting a task automated the traditional programming way, because some human, some member of our species has to think about every single line of code, right? Somebody has to have thought about whether each little bit is a good idea. And look, humans make mistakes, and maybe some of those thoughts were unwise, and that's how bugs get in, or, bad technology gets built. You've all seen it, you all know it. But the point is that some member of the human race, maybe it's not the developer who's currently writing it, maybe they imported a package, but somebody, some human had to have thought about every single line. That is not true in AI. In AI, there are only real 2 lines of instructions. So before, if you needed to write 1,000, 10,000, 1,000,000 lines of code to get a task automated, there are only 2 real lines in AI and machine learning. And here they are. Optimize this goal on that data set, go. That's it. It all boils down just to 2 lines. That's kind of like saying, here's what I like, let me know when one of your monkeys on a typewriter gets there. Minus the combinatorial search space explosion, because this all goes faster than the monkeys, right? The monkey example of monkeys on a typewriter eventually inventing Shakespeare's Hamlet. And yes, it's totally random, so it takes forever. You need the length of the universe to get it. Here, we're doing it faster, but it's the same kind of idea. And you don't notice that when you look at what developers are doing when they're using AI. Because they're sitting there and they're writing all these instructions, and it looks like they're thinking a lot. But here's what they're thinking about. They're thinking about how to get the data, which they don't have to even have looked at or know what's in there, with some library or package that they downloaded from somewhere that they don't have to understand how it works. They're just writing a lot of code, huffing and puffing, to make the 2 play nicely together. But in the equivalent of our monkeys on typewriters example, that's like spending a lot of time just getting the monkeys to sit still behind the typewriter. You're not thinking about the nature of Shakespeare. You're not thinking about whether it was a good idea to make that play in the first place. So there's a lot of wrangling, but it hides that there's very little actual thoughtfulness about the task and what we're trying to do. Now, this is actually incredibly exciting and empowering in one way, because it means that for a lot of tasks, particularly tasks that are nice, small, personal projects, before you had no hope on your own of getting them automated, especially if you don't understand how the task works, and now you can just do it. How cool is that? So it's really empowering. It's really great that we can automate things that we couldn't automate before. But it becomes quite scary when what we are building affects a lot of people. Now we have a thoughtlessness enabler. We can have a very important piece of technology that's going to affect society and the world, built without anyone having thought really carefully about what they're asking for. That's the part that should scare you, and that's the AI-specific ethics issue right there. And so when people ask me, am I scared of AI? What I hear you asking me is, am I scared of human negligence? Because that's the only way that that question makes sense to me. I mean, I don't believe in talking to pet rocks or robot fairy tales. Right? What we're asking is, am I scared that people will build things thoughtlessly without thinking about it, build things that affect a lot of lives? That's the part to be scared of. But actually, I am quite optimistic about our AI future. I think we can do this. But it starts with all of us together understanding that it is our responsibility to re-inject that evaporated thoughtfulness back into these 2 lines. So if you are building something that has the potential to touch a lot of lives, you should be putting as much effort and energy into these 2 lines as you would have into those 10,000, into that 1,000,000 lines of code. You have to think clearly and carefully about it. And that is a job that falls on everyone's shoulders, but especially leaders in these projects. It's important for you to be present if you have that role, to really think critically. So in the last 10 minutes of this talk, I'm going to help you learn to think better about these few lines. I'm going to give you some fun examples and takeaways. So you will learn to always ask, under all circumstances, what's the goal and what's the data set, to think carefully about this. So let's start with what's the goal. And we're going to play a little game because it's too quiet in here. So here's what I want you all to do. You're all going to shout. When I call the number of the photograph out, you're all going to shout cat, not cat. You are going to be my classification system. Are you up for it? Okay, right. So everybody shout loudly so that I can hear you. Number 1, cat. Number 2, not cat. Number 3, cat. Number 4, cat. Number 5, not cat. Number 6. Excuse me? Big cat? Maybe cat? That's not an allowable option. We had two options, cat or not cat, so which is it? And we begin to see what the decision maker is for. Yeah? The answer depends on what you need your system to do for you. So I guess I'd better fill those big boots of the decision maker, and I will tell you that the purpose of this system is to be a pet classifier. So if it says cat, we want it to be saying cat about an animal that in its typical adult form is safe to cuddle and is from the cat family. Now let's try this again. Number 6. Not cat. Now we all agree. And if you're still saying cat, please take out more life insurance. Right? So our first point is that the objective is always subjective. It depends on what we need this system to do. And it also means that if you pick up a system that was built for one purpose and you use it somewhere else, expect it to fail. There's no platonic right answer here on something as simple as what to do with a tiger. Now imagine how much harder it becomes when it's about human issues. So be very careful and be thoughtful about what the purpose was. And don't treat these things like, it's got mathematics on it, so we're talking about pure objectivity. It's on you to remember that that's not true. Number 2, what is the data set? So think about this in terms of a textbook for your machine student to learn from. You are teaching the machine from examples. Right? You're giving your machine textbooks. Now, you might have heard a lot of words about AI bias this and AI bias that. You're probably tired of hearing about all that, so I'm going to condense it down to you into the Hemingway lecture. That is a sad short story in just 6 words. Here we go. AI bias, inappropriate examples never examined. That right there is the problem in AI bias, but it's also the clue to the solution. You are giving your student a textbook. What kind of terrible teacher would you be if you never bothered to actually open the textbook, read through it, make sure that this is what you want to be teaching your student with? Just because it says mathematics on the cover doesn't mean it's a textbook of calculus, right? Doesn't mean it's at the right level for the right age for your student. Maybe it's mathematics for 6-year-olds, who knows? It's up to you, the teacher, to go have a look, see what's inside there. Make sure that it is appropriate. And remember, textbooks and data sets too, they come from humans. And so if it comes from a human who is a jerk who wrote it, that will be reflected in the textbook. It is on you to open it. Now, unfortunately, we saw there are just 2 lines, yeah? This objective on that data set. That means that you could, theoretically, never open the textbook. You just point your system, you go, learn from that textbook over there, don't worry about it. That's where the trouble comes from. You can, but you shouldn't. Always open that textbook. Be a good teacher. Now, those are our 2 lines, and I hope that, since we are automating by example, we will start leading by example as well, and we will make sure to always be asking these questions, whether we're in a capacity as a builder, a leader, or a citizen. Always, always, always be asking about these. And since we're here good with 2, let's add a 3rd one. What if it fails? See, I get asked this question a lot. Why should you trust AI? Like, they're expecting me, since I am an AI professional, to sell AI. You know what my answer is? You shouldn't. Don't trust AI. But also, don't trust humans either. Don't trust anything. What should you do? Test everything. That's what you should do. So how do you know it works? Because you tested it carefully in the conditions that you needed to perform for you. If we tested my cat, not cat, pet recommendation system in the conditions where it was supposed to perform, that does not mean that it's going to work somewhere else for your needs. Test it again. Always be testing. That's where trust comes from. But you know what? Don't trust yourself either. Because when you are the person who designs the test and designs the objectives and designs all that stuff, what if you messed up? Let me show you some examples of wishes gone awry. I'm going to show you some humorous examples. We'll start with non-AI examples so you get the hang of it. I'll also show you an AI example. So here comes the first one. So there's this fellow on Twitter. His name is James Friedman. I quite enjoy some of his antics. So he will Photoshop a photograph for you if you ask him nicely on Twitter. So here's a request. Can you please edit this picture so my brother and I wear the same t-shirt? And he delivers. Here's another one. Can you please adjust this picture to make me look as if I am holding that cliff? Ta-da! Right? The letter of the request is delivered, not the spirit. And it's going to be the same with these systems, so watch out. Now, here's an AI one. Let's say that you make the request of the system. Your objective is learn to efficiently navigate the terrain, right, with your legs. And you forget to mention anything about the arms. Well, that is how you get this arm-swinging idiot. That's because you didn't think carefully about what you were asking for. And when you set up your tests, you ask, does it traverse the terrain efficiently? Great, but then you get this. Now, I'm keeping it light today, so we have fun, but I hope that you have the sufficiently dark imaginations to understand what this actually means when it comes to important human issues. Watch out, be vigilant. And please remember that AI isn't magic. It doesn't read your mind. You say what you want, it either fails and then you don't launch the system, or it delivers it exactly what you wanted. Not what you hoped you were asking for, not what you thought you maybe intended, what you asked for. Whatever your test was. Whatever your test covered, when that test is passed, that's the system you got. So remember, it can't read your mind, and don't even trust yourself. Always remember that you might not have been smart enough to think of everything. So always build safety nets. What if some unanticipated thing happens? Do you have the safety nets? Do you have the way to quickly take it offline and switch in a different system? Do you have that logic built? Do you have a plan? Not for if it goes wrong, but when it goes wrong. Just assume it will, build as if it will, and that's how you keep everybody safe. And so, coming back now, the way that you can really help our AI future, no matter what your role is in it, builder, leader, citizen, whoever you are, take these 3 questions seriously. And whenever you're faced with anything to do with AI, stop talking about robots and science fiction and is it a person, whatever. These are the 3 questions that you should be asking, thinking about, and talking about. What is the goal? What's the data set? And what if it fails? And if you do that, we are all safer already. Our future is really bright. This is not such a difficult habit to get into, but it starts with us. We all have to start doing this. And as I said, I'm optimistic. We've got this. We can do this. Let's build a safer, brighter AI future together. 'Cause tomorrow's AI will be built on what we do today together. Thank you very much.